sound of the cops. When do we hear that sound? When we don't obey the laws. So what am I here to do today? I'm here to explain to you what the laws of exponents are all about. Now, in mathematics, it is vitally important that we stick to these rules, all right, as they guide us through the very complex questions involving exponents. Now, back when I was in school, I used to get very frustrated with this, and to be honest, I don't think any of it actually made sense. Basically, because I wasn't sticking to the rules. I wasn't aware of the rules. So here I am today to remind you, grade 10s, of what we were taught in grade 9. Now, when we look at exponents, all right, exponents and their rules all seem to take place when we have the same base. Now, what is the base? Well, the base is what lies below the power. Now, if I have 5 raised to the power of 3, so 5 cubed, 5 happens to be my base, and 3 is my exponent. Some basic knowledge that we sort of need to understand. Now, when we go to rule number 1, this is stuff that you do know. I'm just recapping to show you where we're going to go to with this information. So rule number 1 states that if I have x raised to the power of m, which could be any value, times x to the power of n, I've just used m and n to show you that these are two different values. This could be a 4, this could be a 3, this could be a 36, this could be a 2, all right? But the rule stays the same, that if my base is the same and I multiply, it means that I need to add my exponents. So for instance, if it was x to the power of 4 times x to the power of 2, the bases are the same, so I'd say x to the power of 4 plus 2, which is 6, so it would be x to the power of 6. You're starting to remember now, aren't you? Number 2, x to the power of m divided by x to the power of n. Well, if we notice, multiplication, now we have division. The bases are the same. Surely, if the rule is to add when we multiply, it should then be the opposite when we divide it, which it is. So it's going to be x to the power of m minus n. For example, x to the power of 7 divided by x to the power of 3. My bases are the same, therefore I say 7 minus 3, which gives me x to the power of 4. Moving on to number 3. I am moving through these fairly quickly because this is just revision from last year. If I have x to the power of m in a bracket raised to a further power, right? Now we have a power to a power. It's a very powerful sum. So what we need to do here is that we say that x to the power of m is now going to get multiplied. So if we have a power raised to a power, we need to multiply those exponents. So for instance, if I had x raised to the power of 5 in a bracket, and then outside the bracket I had a 6, that would then be x to the power of 5 times 6, and my answer would be x to the power of 30. Just to sort of explain that to you and where that rule comes from, all right, is the fact that if I have x to the power of 5 raised to the power of 6, I'm telling you that all you need to do is multiply. But in effect, what does it mean? It means this bracket times itself 6 times. So if I had x to the power of 5 times 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 x to the power of 5, I'll put another one here, I'm running out of space. And I have 1, 2, 3, 4, 5, 6 of them. Let's go back to rule number 1. If I multiply and the bases are the same, what am I doing to my exponents? Well, I'm adding them. So 5 plus 5 is 10, 15, 20, 25, 30. Notice how I got to the same answer. So this is basically just the shortcut. Mathematics giving you all those reasons to do things quickly and efficiently. But there it is, just explained for you so that it actually makes sense. Now, because that's what we're here at Qlick to do. We're here to make sense to you, all right? And have it as an enjoyable experience and not so frustrating. Last one here, of number 4, we've got x to the power of m times y to the power of m. Now my bases aren't the same, but how we can write it is like this. In a bracket, x times y raised to the power of m. Now this is almost done in reverse because often your question will be this. If you have x, y raised to the power of 6, the common mistake is that I'm going to write this as x, y to the power of 6. Now this does not equal that. Why? Because now all you're doing is you're saying this 6 only applies to the y, which it doesn't. It applies to both of the variables. So the correct answer, all right, would be x to the power of 6, y to the power of 6. That's the correct answer. So it's almost like you can do this in reverse. It's just to explain the concept to you. Right, now that we're done with these, this is just the revision side of things. We're now going to move on to the 2 laws which we have also learned about before, but I just really want to run through them one more time. So, this law is the one that x to the power of 0, right, is equal to 1. Now, this is often a misconception as to anything being raised to the power of 0. Surely, anything multiplied by 0 is going to be 0. But this is the issue, because along with that misconception comes this whole thing of 3 to the power of 2. Sometimes we quickly think, oh, that means 3 times 2. It doesn't, which is the same reason as to why this does not mean x times 0. It is x being raised to 0 amount of times, and that happens to give us a 1. Now, we're not going to delve into that too much now, but what we need to understand from this is that anything raised to the power of 0 is going to give us 1. Please note, I've been using x's the entire time I've been doing this video. That does not mean it only applies when we have a variable of x. We can have a variable of y, we can have a variable of z or p or q, whichever letter you choose. So please don't become too familiar with just seeing an x, and I'll give an example soon. So here we are, that anything raised to the power of 0 is going to give us 1. The most important one now is x raised to the power of a negative n. So here we have a base, being x, getting raised to the power of a negative exponent. What does that mean? What it means is that if I have a base being raised to a negative power, it means that that base is not a whole number. All right? It means it's a fraction of a number. So in order for me to explain this to you, all right, and tell you that this is actually a fraction of a number, what happens? How do I solve this? Well, if I'm going to make this a positive exponent, this means that when I see a negative sign, all right, it means that this now is no longer a whole number, so it's going to be 1 over, and the base and the power remain the same. Let me use the orange just to keep it tidy. That's it. That's the answer. All right? So let me do this again. If I have p raised to a negative 3, we know, all right, that this value over here is no longer a whole number. All right? It's a fraction of a number. So we see the negative sign, so we immediately put a 1 over to make it into a fraction. And the base and the power remain the same. Now the next level of that is people are going to say, well, is it always just going to be 1 over? Is that just what it is? Yes, it is 1 over. Why? But why? I'll tell you why. Because what do we find the coefficients of these bases to be? What is the coefficient of this x? I'll tell you right now, it's 1. What's the coefficient of this p? It's 1. So it's the coefficient that becomes the numerator. That's also something that we don't really get taught or get told. So all of a sudden in the test, we now get a question like this. I'm just going to erase this because I like the center of the board here to keep your attention. So what happens if I have 2x to the power of negative 2? What happens if I have 2x to the power of negative 2? Now, the 2 is not being raised to the power of a negative at all. The negative 2 here is applied to the x. So it's not the 2 that no longer becomes a whole number. So what happens? I'm trying to make this into a positive exponent. I know if I've got something raised to a negative power, it's not going to be a whole number. It's actually a fraction of a number. I'm repeating this because it's very, very important that you understand this concept. So this is now, what is my coefficient? It's 2. So let's just keep the same colors. Don't want to confuse you. So the answer to this is going to be 2 over, and now my x and my exponent stay the same, but it's on the bottom now of the fraction. So it now becomes my denominator. And I've now expressed this, all right, with a positive exponent. So what is happening here? Well, what is happening is that if I have a negative exponent on top, I bring it down to the bottom and it becomes positive. If I have a negative exponent on the bottom, I can bring it to the top and it becomes positive, and this would be x to the power of 3. So x to the power of 3 is the same as 1 over x to the power of negative 3. And that does actually make sense. Why does it make sense? And I always like this part. People like say, why? Why is it like that? That's important because this is what we discuss all the time here at Qlick. We want kids to know, why is this possible? How does it happen? So this is how it happens. Let's use numbers. So now I have 1 over 2 to the power of negative 2. Okay? Now, I want this to be written with positive exponents. So what does this effectively mean? This effectively means 1. This line means divide. 1 divided by 2 to the power of negative 2. So we write that out as 1, right? I'm just doing the next step. 1 divided by 2 to the power of negative 2. So, in effect, I've now got 1, all right, divided by, now what is 2 to the power of negative 2 the same as? It's the same as 1 over 2 squared. Right, we should know that. Just rewind in the video if it makes sense to you. Now with fractions, boys and girls, do we multiply? I mean, do we divide? No, we want to multiply. So we turn this into multiplication. It's now 1 over 1. We turn this whole number into a fraction by putting it over 1 times 2 to the power of 2 over 1. Why did that flip around? Because when we divide with fractions, right, and we turn it into a multiplication, it's called the tip and times. Go back into your textbook, far back, all the way to grade 8, or even grade 7, and that will remind you. So now I've got 1 over 1 times 2 squared over 1. What's my answer going to be? Well, 1 times 2 squared is 2 squared, and 1 times 1 is 1. And that equals, what is 2 squared? 4 over 1. What's that equal to? 4. So the reason I'm telling you is that if you have 1 over 2 to the power of negative 2, I said you can bring this to the top, and it becomes positive. So 1 over 2 to the power of negative 2 is the same as 2 squared, which is 4. Notice how these are exactly the same answers. I've just explained it to you so that it makes sense, so that you can now tackle all those sums that you've been given. Now, there are a couple of different ways that we can approach this sum, but the first thing I'd like to tell you is that, yes, often now in grade 10, they're going to tell you that they want your final answer expressed or written with positive exponents, and that's absolutely fine. That's what they expect of us, and that's what you should be doing. But I don't think it's necessary, all right, to do that right now. Rather leave it for the final answer. Once you have your final answer, then go ahead and exchange and turn things into positive exponents, whether you bring them from the bottom up or you're taking them from the top and putting them to the bottom in order for them to become positive. So what I'd like to do here is I'd like to do the normal sum. What do we have? We've got 2 terms, all right? The top term, 3x, y to the power of 0, z to the power of negative 2. This line means divide. Divided by 6x to the power of negative 1, y to the power of negative 1, z. Now, I often say that if there's no exponent, why don't you just put in that 1? Because it sometimes helps us when we're dealing with lots of negatives and we're minusing. So first things first, I need to simplify this. So we deal with the coefficients first. 3 over 6. 3 divided by 6. Now we know that this is not bigger than the 6, so it's going to be a fraction of a number. So I can simplify it to be 1 over 2. Because 3 goes into itself once and it goes into 6 twice. Then I move to the x's. Now remember from the rules that I told you at the beginning of this episode, is that if I have bases that are the same and I'm dividing, I need to subtract the exponents. And we start at the top, we say 1 minus a minus 1. Now if I have 1 minus a minus 1, we'll write this on the side, 1 minus a minus 1. I need to put that in brackets because this then becomes, by multiplying out this bracket, becomes 1 plus 1, because a minus times a minus is a plus. So 1 minus minus 1 becomes x to the power of, I'm going to write it on top here, this is going to go away, and this is going to become x to the power of 2 on top. Now I have y to the power of 0 over y to the power of negative 1. It's 0 minus a minus 1. What is 0 minus a minus 1? I need to put in a bracket, it becomes 0 plus 1, which is equal to 1. So now this is going to become y to the power of 1 on top. Then the last thing I have here is z to the power of negative 2 over z to the power of 1. What happens there? Well, I've got a negative 2, all right, minus 1. And what does that equal? Negative 3. So this is going to go away, and on top I've now got z to the power of negative 3. So let's rewrite this so we can see where we are. We've got 1 x squared y1 z to the power of negative 3 all over 2. Is that my final answer? Well, it isn't, because they've asked us to make sure that we leave our final answer in positive exponents. So do I see any negative exponents here? Yes, I do. Here it is. Z to the power of negative 3. Where will it become positive? Down below. It's on top as a negative, so down below it becomes positive. So you simply just write this as 1 x squared y to the power of 1 all over 2 to the power of z, 2z, sorry, to the power of 3. Now please excuse me for using simple terms and writing a 1 before the x squared y. And that is just to show to you that it's there. 1 doesn't have to be there. It's still going to be the same answer if I leave it like that, and it's still going to be the same answer if I leave that out. Because anything raised to the power of 1 stays the same, and 1 before any variable is not necessary, but it's just a reminder that there is an imaginary 1 over there. So that's what your answer would be. So we now go on to things like exponential equations. So I'm not going to delve too deep into this, but I'm going to show you 2 examples, and then I'm going to give you some homework. So the first example I want to show you is this. 2 to the power of x is equal to 8. So 2 to the power of x is equal to 8. We know we have an equation that is an equal sign, and we know we're trying to solve for x. So 2 to the power of what gives me 8? We should know that it's 2 to the power of 3. It is. Because if x was 3, 2 to the power of 3 is 2 times 2 times 2, which gives me 8. 2 times 2 is 4, times 2 is 8. And that's what x is going to be. But how would I work it out? How do I get to that? Because it's not always going to be something I can do through observation. So with exponential equations, I'm going to briefly explain it to you, is that in order for us to be able to solve for this x and bring it down so that it's x and other numbers, my bases need to be the same. So can I write 8 as a 2 to the power of something? Yes, I can. So I can say 2 to the power of x is equal to 2 to the power of 3. Now we're getting there. Hey, that click is coming. So now because my bases are the same, I can drop them, and I now just write x is equal to 3. That's the first one. The next one that I want to do is, what if we have something like this? What if we have 2 to the power of x plus 1 is equal to 16? Well, I said, we're trying to access this x. That's what we're trying to get to. But we can't access that if this base is 2 and that base is 16. Can the 16 be written as a 2? It can. 2 to the power of 4. So now I have 2 to the power of x plus 1 is equal to 2 to the power of 4. Brilliant. My bases are the same, so I can drop them, and I've now got x plus 1 is equal to 4. We've still got some cleaning up to do, so x is equal to 4. We take this across and it becomes a minus 1, so it's 4 minus 1, so x is equal to 3. What if I have 3.5x plus 1, going real next level, is equal to 15. Now, just like a normal equation, we're trying to isolate x. We're trying to get x on its own. And right now, it's got a base of 5, but it's also being multiplied by 3. So how can I get rid of this 3? Well, I need to divide both of these sides by 3. So what I do to one side, I do to the other. So these will cancel out, and I'm left with 5. X plus 1 is equal to, what's 15 divided by 3? 5. Now all of a sudden, my bases are the same, so I can drop them. But hold on, if I just drop this, won't I have nothing here to show? I will, remember. Any number without an exponent always has an imaginary 1. So now I've got x, I drop these, I've now got x plus 1 is equal to 1. So we take the 1 across, so x is equal to 1 minus 1, so x is equal to 0. And that is allowed. X can be equal to 0. So what they're saying here is x is equal to 0, so 0 plus 1 is 1. So 5 to the power of 1 is just 5, isn't it? What's 3 times 5? 15. So it makes sense. Alright? That is allowed. Don't think I've made a little mistake here. We always are honest about our mistakes, and we do make them. We've made a lot of them. But that is correct. And I'm going to leave you with something. And I want you to solve this for me. And I want you to tell me in the comments below what the answer to this sum is. It's going to be a bit of a challenging one. You've got 2 dot 5 to the power of 2x is equal to 50. What's x? What's the value of x? Well, I'll leave that to you. It's time for you to do some work. Drop a comment. Did you like this video? Did it explain? Did I manage to get this message across to you guys? That's all we care about. So until next time, keep clicking.